I'm John Flack.
I'm Patrick Gomez.
And my name is Ankit Virendra, and this is our EDD project, No Flashy Hot Hot. So our problem statement is that between 2014 and 2016, over 1,200 people were either injured or killed in electrical or battery fires in the US due to hydrogen fluoride and other toxic gases being present in its emissions, according to topical fire reports. Our statement of purpose is to design, build, and test a device that will lessen the amount of injuries and deaths in electrical fires in the United States. So, some of our key research has brought back this. 7.5% of major fires are caused by electrical malfunction. The extreme heat, poisonous flames, and risk of battery explosion makes battery fires a risk that not even firefighters are often equipped to deal with. Smoke, including hydrogen fluoride and other gases, is known to cause chemical burns, blindness, cancer, and more upon ingestion. Batteries cannot have their source taken away, so fires can reignite hours after being put out. Okay, some of our key survey results show this. Our target user and consumer would be firefighters and hobbyists between ages 30 and 60, with a high school education and possibly a college degree, primarily located in the United States. Our market analysis brought back this data. When asked how the extinguisher should be deposited onto the fire, most people believe that it should be with a turreted hose that could rotate up and down to point exactly towards the fire. As for how this product should move, it would just be a simple solution of just 4 wheels powered by motors to drive around. The way that the system is going to be powered is using nickel metal hydride batteries, and it's going to monitor fires using a combination of a thermal camera and a regular camera used in tandem, so that the thermal camera can detect the source of heat of the fire, but the regular camera can also detect other objects and obstacles that might be in the way and navigate around them. The type of extinguisher that we ended up settling on was R123, a refrigerant primarily, but also can be used as an extinguishant that is chemically safe to ingest, of course not in large amounts. The storage of extinguishant, however, would be done through a large gallon tank that can be refillable. The control system that we settled on was a combination of autonomous with human input, where it could primarily control things on its own, but also, if needed, a human could come in and make other adjustments. The way that the visibility method, the way that other people are going to be able to see this, was through LEDs.
So there's a number of different laws and codes that we had to follow with our device. So mainly because we're using CO2, a lot of the laws that we have to follow are CO2 related and how we store and develop the CO2. So the 3 rules that we mainly had to follow were 1910, 101A, B, and C. And these pretty much are saying that in part A, we have to specifically visually inspect our CO2 cylinders to make sure that they're in a safe usage so that they don't have chunks missing, they're just visually, they look safe. The second part is saying that when we're using the tanks in a motor vehicle or portable object, they need to be securely fastened to the vehicle so that if the vehicle were to flip or get off railed or something like that, the tank isn't going to go flying and then potentially become a projectile. And then the third section is saying that all of the CO2 tanks have to have what's called a blow-off valve. And this valve is so that if the CO2 tank is overfilled or if the tank heats up and there's too much pressure inside, this valve is going to just blow. So the valve will explode off and just vent the tank out so that the entire tank doesn't explode as a whole and become a large explosive device.
The first solution we were able to find was a hoisted intelligent mobile fire extinguishing system. This would be able to be mounted into a tunnel, and if there was a fire that erupted in this tunnel, then it would be able to put that out. It was semi-autonomous, and it did not meet the versatility we were looking for because it's only able to be mounted in a tunnel and therefore cannot go in multiple different terrains and different environments. But we did feel like this was a very this did perform well because it would perform well because it was inside of a tunnel and it did monitor the fire. Our next system that we found, or solution that we found, is a heat management and automatic fire extinguishing system for vehicle batteries. Basically, it was a system that would go inside the pack for a battery for a vehicle, such as an electric car. And if the fire erupted, the batteries got caught on fire, it would fill the entire container with foam to neutralize the fire. We found a couple issues with this. This is not very versatile since it can only work if it's with the batteries and installed with the car. We felt that this does monitor the system because it was able to put out the fire initially, but it only works this one time. So if anything, if a battery reignites or something, which it does happen, it would not be able to put it out a second time. And because of it fills everything with foam, nothing would be able to, you could not reuse anything, and we felt this was a problem. The next solution we found was a lithium-ion battery fire test cabinet with self-assembled automatic alarm and fire extinguishing system. This is basically a cabinet that has that you can store electronics inside of, and if anything catches on fire, then it will automatically put that out, and it does monitor the fire. The only thing is we feel that because it only monitors within, and it cannot, that's the only thing that's detecting. It's not super versatile since it cannot be used in multiple situations. And reusability of the electronics would not be high since it's going to extinguish everything within the cabinet instead of just whatever is on fire directly. And so, and a good thing about the system is that it does not put the user in any harm or any danger because the cabinet is fully enclosed. And last but not least, we have a Class C fire extinguisher, which is being used by an individual to put out the fire. So Class C fire extinguishers can put out battery fires. They're very effective at this. The only problem is because it is just a fire extinguisher, a person would have to monitor the fire, and there would not be, like, there's nothing autonomous about this system. It is just a person next to the fire putting it out, and having to wait and make sure that the fire does not reignite. This puts a lot of danger in the user because they have to put the fire out themselves, although it is very easy to use, and it is a very versatile system because you can bring it anywhere, because it's just a fire extinguisher. So with all these in mind, we set out to create our criteria and constraints for this project. We felt that this product needed to be fire resistant as it was putting out fires, and if it came in contact with anything, which is a very big possibility, we did not want the product to create any more danger. We needed this product to be able to have a long battery life so that it could, or at least be able to stay active for a long period of time. Because if this robot or whatever we create is going to monitor a fire, it needs to be able to do it for long periods of time, since battery fires have been known to stay active for very long periods of time. It needed to be able to be very versatile, to be in any situation, any place, any time, and also needed to be easy to lift for people or firefighters. Need to carry as much extinguishing as possible so that it could continue to extinguish the fires as they reignite, and it needs to be very easy to power off and on, be very safe for the user, cover it as much as possible to make it not dangerous, and also we want it to be bright and easy to see in low light environments, since fire does create smoke. And so we wanted it to be very visible, so it wouldn't cause any issues or create any more danger. Our only constraints were that it needed to put out the fires, it needed to be able to put out those fires autonomously, and it needed to be a rechargeable system so that it could be recharged and powered again. Our final solution was a turreted hose on a wheelbase with a refillable extinguishment system to put out the fires, and with an infrared camera and a regular camera working in tandem. to be able to detect the fires and for the robot to be able to put out the fires. The original design that we came up with, which is shown by this CAD model, shows us having two different containers, one for CO2 and one for a different extinguishant. Initially, we were going to use R123, which is a type of liquid that is very good at putting out battery fires. And we ended up changing this later because of BattleBots said that they would allow us to go in their show and bring this robot for testing. Obviously, that did not happen because of COVID. But because of this, they requested that we switch to CO2 because it is a lot easier to manage and it's something that they use quite often. And it is capable of putting out battery fires and such. So we decided to use that. And as you can see here, our final design is very similar to the initial design, the same drive base and such. We did change the position of the tank. This was because the refilling is a lot easier and more consistent if the tank is in this orientation, vertical orientation. And we put it in the back since this was the location that we were originally going to put the other big tank. And it ended up working quite well, as you'll get to see in our testing later. We ended up having to change the motor that powers the tilt of the turret. This is because the motor we planned on using initially was no longer available, and luckily John Flack had an extra motor that we could use, and it worked out quite well. Also, it is, you can see, in the new design, we added a lot of lights and to make sure that, and we painted the whole robot yellow. This makes sure that it's a very bright robot and it's very easy to be seen. This would meet our criteria of being very bright and easy to see in low light environments, which is very important for this solution. We have lights on the back and the front of the robot, as well as rotating lights from a fire truck. They allow us to light up the environment, and they work extremely well, as you'll get to see later. We also tucked away all of the pneumatics and such more inside of the frame to be more fire resistant.
All right, so this is a little bit about how we built the product. So these plates we put them all together and tack welded them all to create a 3D structure that we are using as the chassis of the item. So once we had the frame made, we screwed on some drive shafts and drive wheels and put in some gearboxes, and then connected the gearboxes to the wheels with chain. So once we put those together, we had to actually start working on the turret. So for the turret, we took a few plates that were aluminum and machined, and we welded them together to a base and inserted a shaft and some bearings. And the shaft and bearings would support the turret on the front that says EDD on it. So then there's a whole gear reduction system inside this turret plating that has chains that run through it. It gives the motor a reduced RPM value so that the turret on the end is actually very easily controlled using remote signals. So once we had the turret back from the school, we actually got to mount the motor to it and finish all the chain runs and add some high voltage tubes so that the wires can cross over the frame pretty easily. So this is a little video of us testing the turret. So right now we're just manually giving the motor some voltage in order to move the turret up and down, just to ensure that the speed is all right and that it's not going to move insanely fast or slow. So the reduced voltages were moved at a decent speed so that the sensors are able to actually control it. So once we're still working at home at this point, but we had to finish the robot still. So I took some steel plates that I had spare from a different project and cut them and test fit them onto the BattleBots frame that we were using as still as a test bed for this project. And once we had those cut, we welded a few little lips onto it and mounted some red and blue LEDs, as well as some custom designed like search and rescue lights. So these lights spin around and scan the area with a white light so that it's very visible. I'm still working on this test dummy frame at work, and Patrick currently has the actual driving robot at his house. So I took him the turret, and he had the turret at his house, and he installed the batteries and the turret into the No Flashy Hot frame, and pretty much we had it all hooked together except for the lighting and the CO2 system. We still had the base frame at my shop, and to kind of fix this up to make sure it was going to fit everything, I had to cut some more plates and help make sure that the CO2 tank was very securely fastened into the device. I met up with Patrick and picked up the rest of the robot, and then we gave it a nice coat of neon yellow paint, and then reinstalled everything inside of it. So this is what the final product looks like. Alright, so testing. So this is the first test that we ran, and this test is pretty much determining that the device is able to be seen when it turns a corner. So we're starting out with the product out of camera, and then as it moves into frame, you can actually see that the product is extremely visible, and that you need to, if you're driving in a car on the highway, you will definitely be able to see that there's a device in the road, and you will know to move over so that you don't hit it. So this next test is an acceleration test. So we're starting off by just slowly hitting the throttle to spin the robot in a circle to make sure that it can spin in a circle on its own freely. After it's done spinning and seeing that the product can turn on its own, we're quickly accelerating the product from 0 miles an hour to about 30 miles an hour in about maybe 10 or 15 feet. So this has kind of confirmed that the device is extremely responsive to signals, and it's able to turn on its own as well as accelerate extremely rapidly if the situation presents itself. So this test is a strength test. So if there's a situation where there's an electric vehicle in the middle of a roadway on fire, it's obstructing traffic. So we figured our device needs to be able to push this car out of the way. So currently there's about 4,000 pounds of lead weights inside of the black tub, and we are pushing it with our device to kind of show that the product is readily available to move a Tesla out of the road if there is a fire in the middle of a roadway. So at this point, we knew the device could drive. We knew the device could push a car out of the way if it's in the middle of a roadway, but we still didn't know if it could actually do its intended purpose, which is put out a fire. So to test this, we had a few small CO2 canisters that are about the size of a soda bottle, and we hooked them up to the valve system, and we used them to pretty much extinguish a blowtorch that was put in front. And this test was conclusive, and we learned that even with a small amount of CO2, this device is capable of putting out a fire on its own. For this, we actually talked to a local fire department and got them to give us permission to test our product near their station so that if anything had gone wrong, there's an actual fireman on scene to help us handle the situation accordingly. So in this test, we're doing manual controls because the computer is still having some issues with detecting fire versus the body heat of humans and some other things. So we turned on the CO2 valve with a remote control and aimed the turret with a remote control and just drove the device up to a fire, and after about 10 seconds of flooding the fire with liquid CO2, the CO2 was able to aerosolize and completely smother the fire. While we were there, we got a lot of really good advice, and the main thing was that the firemen really thought that this product was going to be useful. So some of them had experience with a Tesla on fire, and they'd experienced the problem where it's extremely dangerous. But they had looked over our device and made sure it looked safe, and once we tested it, they were kind of influenced that if this product was better made so that it looked a little bit not jank, it would be a lot better for the departments to use compared to a fireman rushing a Tesla on fire with a CO2 extinguisher.
In this video here, what you see is that this was one of my initial tests to try to detect the color red, which is what I'd be receiving from the thermal camera, and use that to try to determine where the fire is. You see me pulling out a red the red side of a Rubik's Cube, and adjusting some sliders that I had made in Python to try to only center in on the range of colors that would be for the red there. You'll see me throughout this video slightly tweaking and adjusting these values so that it only captures the cube, but tries to get as square of an image as possible without cutting off corners. This test here it's not to see what the exact values I'd be using in real life is, but just more of to test my tuning system itself, so I could so that when I have the actual data, I could use that to determine what the slider values should be. This is just to see if the system works. Alright, so in this test, what happened was I wanted to use the same idea that I'd done with the red Rubik's Cube, but I wanted to implement it on what an actual fire would be like. So what you will see me doing here is I'm lighting, I have a candle there, and I'm doing the same adjustment of values so I could hone in on the bright white of the light there. It worked okay, but a large issue that I felt was that this is something that would only work when done in almost near darkness, but plenty of fires will be happening in broad daylight. In those cases, it might not be as distinguishable to read between the light of the fire and the light of just general ambience. So this really showed how important it was to have a thermal camera and this, because a thermal camera would be able to identify not just light, but heat, and that's the important factor there. In my last and most successful test, what I'm doing now is tracking the blue of the cube. You see that in real time it is moving wherever I am taking it, and you have it's both setting a radius and coordinates to it, so I could track the position it is on the screen and the size of it. As I'm now making the blue area of the Rubik's Cube even smaller, the radius also decreases. What this could be used for is that you could use the X and Y coordinates to determine if the drivetrain needs to turn left or right, or if the turret needs to go up and down. But if the radius is too small, that means that the fire is too far away, which means that we could drive closer to it. If the radius is perhaps too big, then we need to drive further away to give ourselves some more distance.
The reflection. So in the future, the device has a few things that need to be changed. This revision was obviously very heavy and very large because the device was a reused fighting robot, so it had a lot of parts on it that were just way overkill on the strength scale for what we needed. So in the future, we're going to make this product smaller and lighter and just a little bit easier to manipulate so that firemen can either lift the device or drive the device out of the back of a truck. We also are going to, in the future, will fully enclose the frame so that there's zero risk for fire to get inside the device and potentially damage the internals. With the hose, there was a few issues with the hosing where it would freeze up. So in the future, we're going to use larger diameter hose as well as with a fiberglass coating so that the CO2 can flow a lot faster and not freeze as much. And then we also need to add a pressure zone, which is going to allow the liquid CO2 to aerosolize more. And when it aerosolizes, it will be able to coat a larger area and put out more fire. So in the future, we need to make this product a little bit easier to produce. There's a lot of moving parts that don't need to exist in here because the product was kind of a revised from something else because we didn't have the resources to make it from scratch. So in the future, we'd have to definitely make the product easier to use and produce. So we also would need to do a little bit more testing with the vision tracking systems, because while the systems were good, there were times where it would mistake a human for a fire and potentially chase after someone and try to put them out.